CEO of Microchain Blockchain Technology Company, and we are the backup of the MOAC project. And today, I'm very glad that I have a chance to you know, do a little bit more introduction about what MOAC project is, and we want to do a little bit into the detail about how to utilize the microchain and the mother chain layout of our project, and how to set up a microchain and make it work. So I assume attendees today, you know already know a lot about blockchain already. So I want to do in two steps. One is going through the overall MOAC architecture, and then the second part will we will dive into the real code and walk through the step-by-step to set up a microchain and deploy a simple application or a simple smart contract. Okay, I'm going to share my screen right now. Okay, hopefully, can you guys see this? Okay, I'm going to give some quick introduction about the MOAC architecture. So when we look into the blockchain space, we always talking about three very important problems we need to solve. And this is the trilemma problem brought up by Ethereum. And so basically it says in a blockchain setup, it's very difficult to achieve security, scalability, and decentralization at the same time. To give an example, like Ethereum, it has a up to date, it's about like maybe 20,000 nodes in the network. And so the decentralization is pretty good, and the security is very good. If you want to attack Ethereum network, it's pretty difficult. However, the scalability is not that good, meaning if we have a like 20,000 node right now, if I double the size to 40,000, but the processing power doesn't double, actually it just stays the same. So the scalability is not that good. So on the other hand, like EOS, you try to increase the scalability, doing the by a parallel processing and increase the transaction per second. However, the decentralization is not that great because it only has 21 supernodes. And another section is like, if we look at the sidechain solutions, they typically will, have a decentralization because have a blockchain and many sidechains, and scalability is pretty good, but security is not that good because for the sidechain, it's very easy to attack given the size of the sidechain itself. So, and what we want to do is MOAC wanted to solve this. We wanted to have a blockchain project which can solve these three problems at the same time. And I found that it's not difficult. It's very difficult to solve the problem in just one blockchain. But if we have a two-layer architecture, and we think we can solve that problem. So basically, we have a bottom layer we will call a mother chain, which is will provide the security and decentralization for the whole system. And it's based on POW, and it can support many more nodes, like just like Ethereum. It could be consists of 10,000 nodes. And on the top, it's upper layer, we call it microchain. So each microchain is a small set of blockchain that processing a specific project at one time. So in that way, in the upper layer, we will provide scalability for the whole system. Okay, so how we do this? So basically, when we deploy a smart contract, we'll deploy smart contract as a microchain rather than just a piece of code in like Ethereum. So each smart contract can select its mining node, consensus protocol, and rewards. And each microchain can store its data storage for the best throughput without, affect other microchains. So that's reduce the pressure to store everything in the mother chain. So give a quick idea about cross-chain. So it will be very easy to implement cross-chain features with microchains. You can assume that microchain consists of a lot of nodes. Each node can cross another blockchain and our MOAC blockchain, and they form a customized consensus protocol. And all this communication between like Ethereum and MOAC will be handled in a decentralized way. And basically, if you push this concept a little further, you can see that the similar concept can be utilized to cross other network with MOAC network or external network with MOAC. And we have already implementation for cross IPFS network and MOAC, and the implementation will call Firestorm. So if we, each microchain could be the base for a application. That's just like most blockchain does, and it's so obvious. But we can go a little bit further. So if we have a microchain which doing a specific task with its customized consensus protocol, like one microchain doing POS, one microchain doing IPFS network storage, and another microchain doing zero knowledge verification, and maybe another microchain will doing the IoT network. So with those microchains enabled, we can treat them as a service. Now you can build a application on top of multiple microchains, meaning you can create a very powerful application on top of multiple microchain services. So that's improved dramatically compared to the traditional single blockchain have a single set of features. Okay, so open ecosystem. I don't want to touch this today because it's like second layer mining, but you just make it open and get a positive network, positive feedback loop. Okay, so when we look back, so 2008 Bitcoin was first introduced so that everybody can use token without middleman. We'll get rid of the bank. And when Ethereum was introduced, it's so easy to deploy token. So everyone can deploy token by just implement a ERC20 smart contract. Now with MOAC, we want to make it so easy to deploy a microchain. And so every application will correspond to one microchain or over multiple microchain services. And we will oversee that in the future, that will be a lot of chains, and we'll hope the MOAC will be the foundation of Internet of Chains. Okay, so that's the overall overview of the MOAC the MOAC architecture. So today I want to really get into the details of the technical. So I want to do this. So so I'll do decode MOAC architecture microchain demo. So we talk about MOAC project. The major difference is we're using microchain over mother chain. So as I said, Microchain is different than other technologies. So why we want to use Microchain rather than just deploy a smart contract? Okay, scalability first. Smart contract as is a microchain. So we will provide a parallel processing which will process multiple microchains at the same time, meaning we will speed up by the number of microchains. And flexibility. So each microchain can have its own consensus module, consensus protocol, which you can choose. Well, you can always select from the standard pool, and we will provide a proc win. We call it proc win. It's like a POS processing, POS consensus protocol. But you can always customize and create your own consensus protocol. And it will generate block independently, maybe 10 seconds, 20 seconds, or even 1 minute. It's up to what your application is. And each microchain has localized state storage. You can store the state in your microchain just specifically for your application purpose. And security, that's a major difference between microchain and sidechain. So the microchain is backed up by mother chain, and it will have the same level of security as mother chain. I will cover it a little bit later. So we talk about expense. So we will make microchain deployment very easy. Hopefully just one click, you can deploy a microchain. And another great feature of microchain is for your DAPP user, the user don't need to pay any fee to your application. So it's different than Ethereum. So if you deploy a Ethereum smart contract, when user want to call the smart contract function, they need to pay gas, which is very expensive. Well, expensive is one side. The other side is it requires user to have Ether beforehand, which is a very, very great demand for the user, meaning you will turn off all the users without any Ether. Okay, so also microchain is a very powerful features, as I said in the early slides. We have cross-chain features and microchain as service. So here I have a table that compare smart contract and sidechain with microchain. So scalability is, smart contract because we compare smart contract in Ethereum. Basically, it's very slow. Everybody knows the TPS is low. And for microchain, because it processing separately, it's pretty high. And sidechain have a separate chain to do the job, so it will be very high as well. Flexibility, smart contract is low because it's limited to the baseline blockchain, like the consensus protocol and the block generation frequency, like 10 seconds or 15 seconds, it's limited. And for the microchain sidechain, because it's a separate chain, it's pretty high. And security, smart contract is on top of Ethereum, so it has the same level, security level as Ethereum. It's pretty good. Microchain, it's backed up by the bottom mother chain. The security is pretty high as well. Sidechain, but on the other hand, it's on its own, so it's easy to be attacked. So expense, if you want to deploy a smart contract, it's pretty low. You can just spend maybe a couple of dollars. You can deploy a smart contract. And in microchain, it's same. If you want to deploy a microchain, we make it very simple. You can always select nodes from the pool. I will cover it a little bit later. But for sidechain, if you want to deploy a sidechain, it's very high, meaning you need to deploy multiple miners. One is miners, and also you need to deploy multiple servers. basically you want to deploy a separate blockchain, even it only consists maybe like 20 nodes, you still need to deploy 20 servers. So when you call a smart contract, the cost is actually very high because, you know, whenever you need to call smart contract, you need to pay the gas. And like in existing Ethereum system, you probably need to pay maybe like $1 for a smart contract execution. Assume, like, consider you have like thousands of calls on a smart contract each day, then the cost will be very high. So on Microchain, on the other hand, we get rid of the gas requirement on the blockchain. So it's zero basically. Any user, they can just download your DAPP and they can start to use your DAPP right away. They don't need to pay any gas. Well, in the Sidechain case, they may reduce gas and in their token, but still there's some amount of gas. They can make it low though, depending on what they set up. So let's look at the storage. Well, we know that store something in smart contract in Ethereum is very, very expensive because the storage is limited. And in Microchain, it's pretty low. It has a separate blockchain to store the data, which is same case as Sidechain. And for maintenance, in smart contract in Ethereum, the maintenance is zero. Basically, you just need to deploy once, and the smart contract can be used forever unless it's killed. So in Microchain, the maintenance is low. So basically, for the application developer, you just need to pay the miner. You don't need to, you know, maintain the servers. That's it, which is the case for the sidechain. You know, the maintenance was very high. You need to, you know, even it's 20 nodes sidechain or 100 nodes sidechain, you still need to maintain those 20 servers or 100 servers. Okay, so this is the overall comparison. Let's take a look what MOAC system look like. Okay, as I said earlier, we have two layers. Bottom, we call it mother chain, and on top of it, we call it microchain. So in the bottom, it's a globally consistent blockchain, just similar to Ethereum. It has a two type of nodes. One is mining nodes, and the other one is we call it V nodes. Well, basically that's the same. They install the same program. They install the same application. Just one has like GPU capability, so they can do mining, and the other one they probably do not have GPU. Their mining is meaningless. So, but in our system, they can provide a access point for the top layer. So we call it a vNode pool. And on the top layer, on the above layer, we have a lot of nodes. We call it SCS nodes, smart contract server nodes. So these nodes can register into a pool. We call it a pool. Each pool has its, you know, we call it protocol. Like one pool is POS protocol. One pool is like proc wind. That's the name we call for POS like consensus model. So a lot of nodes can join into the pool, and they'll be ready to be rent for microchains. So they join the pool first, and then if someone wants to deploy a microchain, they just rent maybe 100 nodes out of the pool and work for one microchain. And the another microchain comes in, you can maybe rent maybe 20 nodes out of the pool and make 20 nodes work for that microchain. And that's the way it works. So They maybe multiple pools. They could even be multiple private pools. If you want to deploy a like private network, you can use our setup as well. If you want to deploy a consortium blockchain or microchain, you can do that too, as long as you define the pool and you have the nodes inside available for rent. So between the upper layer and the bottom layer, so when we create a microchain, it will be initiated from bottom, and it will create a microchain and select all the nodes, and periodically those microchain will flush the state into the bottom layer. So the microchain on the top, they will achieve its finality by flushing its state into the bottom layer. And I hope that's give you a rough picture of our MOAC system look like. Okay, so why? So I talked about like microchain is different than sidechain. So and we claim that microchain has the same security as a mother chain, and which is not the case for sidechain. This is because we have a different communication model between nodes inside microchain. So in a sidechain setup, each node in the sidechain, they can communicate to each other. Basically, they form a separate blockchain, and they, whatever P2P communication protocol they use, they will talk to each other. So meaning if one in the sidechain is a bad guy, he can easily attack maybe 20 of its peers and brought down the whole sidechain. But in our microchain setup, it's different. So the nodes inside the microchain, they do not talk to each other directly. So what they do is they communicate with a V node. As I said earlier, the V nodes, they do not do mining, but they provide access entry for the upper layer node. So each SES will connect to a V node, and all the communication between one SES node to the other SES node, they will going through the channel between V nodes. They will reuse the existing P2P network of the lower layer, either by a broadcast method or communication channel method. So in that way, we can avoid a decentralized or distributed DOS between SES, and SES must register with V node and paid by the microchain. Or the traffic will be routed through the bottom layer. So this is very important because that's a great difference between microchain and sidechain. And that's a guarantee that why microchain has a similar level as a mother chain and has a much higher security than sidechains. Okay, briefly talk about this. So let's go back a little bit earlier. So when we do this, we will do some selection, and we want to make it random. Because if you know, in this pool, some nodes may be Byzantine nodes, or some nodes are bad guys. And we want your selection, because we select a small set of nodes, we want to do it randomly. And we want to do it randomly, but that randomness can be verified. So that's the way we select. We compare the address of a node and the microchain address, and we predefine a index. If those two address in the index 2 or 3 are close, this will be selected for this microchain. That's a concept. Okay, so this is the creation overview. So this is the bottom layer, the mother chain, and we will create several smart contracts beforehand. One is vNode pool. It's a smart contract. So all the vNode will register with vNode pool. We have a SES pool, and SES nodes will register, and they need to register with bound. basically, if they, so that created an entry barrier to get rid of the, automatic or, automatic registration, so that if you're doing something badly, your bond will be forfeited. So if we want to deploy, then the next step will deploy a microchain. So we will deploy a smart contract, smart contract. We call it control smart contract, and deploy it in the lower layer. And it has all the microchain control logic in it. So behind the thing, behind the scene, it will, doing the selection, as I said earlier, doing a random selection from the pool. And will all the active nodes, if they are selected, they have to positive acknowledgement. And then if I have enough nodes joining for a microchain, I just create the microchain, and it will start to generating blocks just as a regular blockchain. And afterwards, I can deploy the business logic. Remember, that's on the in the top layer. So control logic. So the blockchain the microchain have two parts. One is control logic. It's in the bottom layer, and the other part is business logic. That's like how your applications handle your specific user request, and it's deployed in the microchain layer. It's on the upper layer. So all the calls to the business logic, we call it direct contract call. So this contract call is not processed by the bottom layer. It's processed on the top layer. And this part will get rid of gas. So doing this, you have to pay gas. But for this, we get rid of the gas. So any user can call the business logic on the application. Okay, so as I said, hold on. Yeah, the presentation will be available in the section after section, and we'll also together with the applications I demoed in this presentation. So as I said earlier, microchain pre-requirement, we have two requirements. So we need to deploy a protocol pool, which all SCS nodes will join in this. And this is a smart contract deployed in Microchain. And or any SCS nodes, if you want to be a member of this pool, you can just download our SCS application. And if you have a network, that's enough. And then you just register yourself as a SCS node inside the pool. And you are available for the microchain to employ you as a node for the microchain. And the other thing is you need to specify a bound, meaning if you are doing bad things, the money will be forfeited. And the second requirement is we will have another vNode pool. It's also a smart contract deployed in Microchain, as I said earlier. And will store a vNode module. It's different than this, but it's just like, this module is same to the miner. So the only difference is miner, they will do GPU mining, but you just doing the provide access service. Okay, so demo setup. So, okay, now I have already deployed the two protocols, and I can check it here. Let me go to this. Hold on. Nodes. Okay, so we have a test network setup. We call it has an ID 101. And so let me refresh. Okay, so There are already 3 protocol pool. That's the SES pool. As I said earlier, we can have multiple pools. So here we have 3 pools already deployed. One is ProcWind David, that's I deployed, and another ProcWind and Firestorm. So ProcWind is just the protocol that process smart contracts, and Firestorm is a specific protocol. It will implement a Filecoin like consensus protocol. So it provides a decentralized file system, which is similar to what Filecoin want to do. And we already implement those. But today we will just try ProcWind. It's just doing smart contract processing. So it has a minimum bound of 1. So if you want to register to this, you can download SES application, but you need to submit at least 1 MOAC token to join this one. And currently already 7 nodes being registered inside this, so available to employ. So I will use this one to start my microchain setup. And this is a vNode pool, as I said earlier. So there's a vNode pool. So this vNode pool will be available for user to connect into. They provide the entry service. So so I have those 2 pools already available. So if later you want to try, you can also using this existing protocol pools. You can always, deploy your own protocol pool, and you have other maybe 2 or 3 SES nodes set up and connect to those. Okay, here it is. So that's the node info. And we have a explorer for the test network running. So this is a test network. What is price? That's the current mining hash, which is pretty low. We only have 1 or 2 GPU miner for this. So you probably don't need to waste your GPU hash power on this. We have one for them. Because you have one, GPU mining, and then will increase hash rate, will reduce the, it will, if you leave, and the network will suffer from a sudden drop of the hash and will make the block generation slower. So if you need token, you can always ask us. We can give you some test tokens you can use. And there's a nice thing about this Explorer. Basically, this is the information about the mother chain. You can also get into this one and check your microchain information. I will show that later. Okay, so let's go back to this. Okay, so now we have a SES pool. I will use this one, and vNode pool I use for this one. Okay, so but still, if I want to start, I want to have some setup locally. So I need to deploy a vNode in my local, which is by this command. So have that one already running. So it's running already. So I can go to the, we provide a wallet application. So we can go to this one. So this one is it's similar to Ethereum wallet, and it connects to the local. So it shows the current block number and my local account. And that's the monitor. I will talk that a little bit later. Okay, so all right, so I'm ready for my first Microchain Creation. So if you want to deploy a microchain, so you first need to, let's go back this a little bit again. So just to refresh your memory, you need to deploy control logic first. Yeah, remember, microchain has two parts. One is the control logic in the bottom layer and business logic in the upper layer. We need to deploy the control logic first. So let's see, I have a contracts and deploy new contract. And I have a, so the contracts here ready, I just copy and paste into this one. And the contract will be available. It's available in our GitHub. So these two contracts. So just copy and paste. It's a little bit big, so it takes a while to compile. So I want to deploy from. Let's wait for this to finish. Okay, no compile errors. So I select the account from account 6, which has like 400 tokens available for this demo. And I will pick up a contract. So there are multiple contracts defined in the source code. So I select this one, subchain base. Subchain base contract has 1, 2, 3, 4, 5, 6 constructor parameter. The first one, you need to specify what the protocol address, the SCS protocol address, like you can get from this one. So this is one I'm going to use for the SCS protocol pool. So I select this, and you also need to specify the vNode protocol base, which is this one I can use. This is, all these are public, but you can, you know, as I said, you can always deploy your own SCS protocol pool and all your own vNode protocol pool. So here I select the public one. And here we'll specify the minimum nodes for your microchain. We'll put in 1. You can specify, if you want to like need 20 nodes, you can specify 20. For maximum, I just for demo purpose, I put 5. So I need a microchain which consists of at least 1 node and at most 5 nodes. And thousands, this is a little bit tricky. So what does this mean? So let's go to this one. So suppose you have 10,000 nodes in the pool, and you only want to select like 100. So meaning you want to select 1% out of those 10,000 nodes. But in our case, we only have 7 nodes. And we want 1 to 5. So meaning I want to using 100%. So meaning this is a 1,000 of 1,000 thousands. And this is a flush round, meaning so we said periodically microchain will flush its state into the bottom layer. So here this is a place you can specify how often the flush happens. So I can put 100 blocks. Okay, so let's see. I'm ready to deploy. Remember, the deployment of this control logic is into mother chain. So see, the gas is pretty high because the smart contract is pretty big. Okay, it's deployed. It's running, you know, waiting for, it's broadcasted the contract into the system and wait for it to be mined by other miners. So it looks like it's done already. We can click on this and it going through the microchain control logic, see what it is. So maximum number 5, which we specified, there is a block reward. The block reward is, you know, we have multiple nodes working for me. And for each block, they generate what amount of token I need to reward them. So meaning all the nodes or these nodes inside this, if they are employed by your microchain, they will getting paid for any block they generated. So that's a reward level. So node list, we skipped it for now. So there are a lot of things we don't need to care about right now. The only thing is we want to see the node count. Node count. So node count is the number that work for your microchain. It currently is 0 because we just set up the control logic. Now we need to tell the SES nodes or select SES nodes to work for us. So let's go back to the slides. So we deployed a microchain control logic already. Next step is calling register open. So what it does is you will automatically select the number of SES nodes working for the microchain. And we're waiting for enough SD nodes to join in. So what it do is we will call register open on the smart contract we just deployed. So we need to start from the creator. So if I execute from another account, it will work. So only the creator is able to open the registration. And we will do SQL. Transaction send. It's broadcast to the network, and the miner sees the network is mining this transaction. So let's wait for a while. One contract has more than 10,000 lines. Well, the control log is a little bit complicated. Yes, the control log is a little bit complicated. Okay, so the register open is already executed in the network, but we need to wait a little bit longer for the, as I said, let's go to the, so okay, here. So we deploy a control logic in the bottom layer and automatically select the nodes based on the parameter we set in the constructor. And you will notify the nodes in the SES pool, and it will determine, each node will determine if itself being selected by this microchain creation. If it is, it will summon another transaction back to the back to this and confirm their enrollment. So we can verify this by going to let's see. So okay, looks like we have something already. So we go back to the smart contract. I said previously we said the node count was 0, right? Now the node count is 4, meaning that have 4 nodes already joined this smart contract. Oh, no, sorry, already joined this control logic. So meaning join this microchain I just created. So we can go to the node list. We can see what's the address of those 4 nodes. So 0 is 7D, 1 is this address, 2 is this address, 4 is this address. So if we look at this, we have 7 nodes available for joining. And I set a limit between 1 and 5. And looks like a 4 joined my microchain. Well, I don't know about these 3. Maybe they are down because they're controlled by the other people. I don't know what they are. But the good news is we already have 4, which reach our minimum requirement, which is, we want at least 1, and we have 4 now. So things is pretty good. So what's the next step? So the next step Next step is we want to call register close, meaning from between the register open call till now, it's open for the SES to join in, and it's automatic. You don't need to, the SES do not need to do it manually. It's automatic. So now we have enough nodes, so we'll call the register close. So this one will trigger microchain initialization and block generation. So we will see. Let's call register close. And remember, we need to use the same owner to call this. So we just fire up this function call, and we go to this and wait it to be mined. And so basically behind the scene, it will notify all those 4 nodes. We have already 4 nodes being joining. They claimed they want to join this microchain. And now register close will notify them. And once they receive the notification, they will start up their, internal logic, and they will do, processing, and they start to doing the block generation. So, okay. Okay, so see any question? One country has more than, that's been answered already. Done, okay. So let's see. So we go back to this. This is a control logic, and we need to know what's happening on the top layer. And this is like, what's the next step then? So next step is we want to have a entry point into the microchain. So we call it monitor. So, okay, so here's the thing. So we have this microchain up and running. Well, remember the business logic is not ready yet. We haven't deployed any business logic yet. But the blockchain is ready, meaning the SES nodes already being selected, and hopefully they already doing block generation behind the scene. But how do I know? So we need a monitor to get into this microchain. Remember, this is a microchain only have 4 nodes, and we have a network, and only those 4 nodes will have the information of this microchain. So we need to have a monitor to be a part of this microchain, and the monitor will provide a RPC service to the outside world. And remember, those SES nodes, they don't provide any kind of RPC service. It's closed. They just do, what a miner should do. They generate blocks, processing smart contracts, processing transactions. They don't provide any service. So in order for us to know the microchain inside information, we need to deploy a monitor. So fortunately, you probably don't need to, so I just want to do a little bit more elaboration about monitor. So this is typically a setup of a DAPP works. So DAPP have a backend. The backend normally need to deploy some kind of connection into the blockchain, and they will normally deploy a monitor as a app developer. They will deploy a monitor for their application purpose. And in our setup, we make it much flexible. Everyone, you can deploy a monitor to this microchain. And if your application or you just want to know this information, you can bring that. So remember how MetaMask works. So MetaMask works is they just like a RPC service to your application. And when you have a plugin in your browser to access MetaMask, every time you want to access Ethereum network, the MetaMask will going through its back-end server, probably one or two multiple connector which connect into the blockchain system. So all your application request is routing through this way. And we call it, this is like single point of failure if you're using MetaMask. If MetaMask service is down, your application loses connection to the blockchain. But in our Microchain setup, if this is down, you can always register another monitor, or even you can have multiple monitors existing at the same time. And each user, they can deploy a monitor as well. They can have the access to the Microchain. So this is a fully decentralized way. But this I just cover a little bit. But for now, but just, you know, for the common use, you can just go into this way. Anyway, so so now I need to register a SES as a monitor. As I said, the monitor need to provide a RPC service, meaning it have a public IP address and a port be open. So I cannot do it in my local. So I have already deployed in the server, and here's the address. So I will just copy this. So what you need to do to register a monitor is you just select register as a monitor, and you provide a monitor wallet address, and you can specify from anyone. And the other thing is you need to spend some money, because as I said, monitor will try to synchronize with other nodes, meaning you will get nodes from those, and you don't want to, you know, someone over, you know, abuse this one and, you know, deploy hundreds of monitors, and then all of a sudden all the nodes will be busy to provide synchronization information to your node. So this node, every time you ask for a block, you need to pay them, basically. So you need to provide some amount for your monitor to be synchronized. If you deploy a monitor earlier, you probably just need to very smaller, much smaller token. And if you want to monitor a really old blockchain, you need to specify a little bit more token to synchronize everything. And we will provide a faster synchronization later. Basically, after, remember, we will flush everything into the block. So ideally, you really just don't need to sync from the beginning. You just need to sync from the point where the last flush happens. Well, anyway, so I'm going to register a monitor. So waited to complete. So now it's complete. Let me, well, behind thing, we'll try to synchronize. Let's go to this one, the Explorer. Let's, hold on, let me have any questions. How can I get the presentation after? We will post it on the website. So we will doing the microchain. So we will, because in our test network, there may be thousands of applications and thousands of microchains, and our Explorer cannot show them at the same time, obviously. So we need to specify the monitor. So you need to specify the monitor address, which is, let me see, where is the, okay. I think it's here. Okay. And the port which I know is this one, which is open to public, and the control microchain address. I need to get a microchain address from here. From here. Okay, this is the microchain I want to monitor. So once I'm done, I get into the microchain information page. Oh, here it is. See, so this is a microchain address, which is I just generated, this one. And remember, we have 4 nodes. These 4 nodes are the miner for this microchain. And, you know, we went through the, this one, you know, 0, 1, 2, 3. We can shoot this, and it shows the same thing here. Okay, 1, 2, 3, 4. And it gave me the microchain balance with 2 and reward. That's the, as I said, that's the miner, whenever they generate a block for the system, it will get a reward. So boundary limit is 1, that's one we specified in the constructor. We have SCSS. VR reward is the reward for the access service. And now we have 55 blocks already being running. We can refresh. Just now was 62 right now. So, okay. All right, so the microchain is running already using 4 existing SCS nodes. And let me go to what's the next step. Oh, okay. So the next step is we want to deploy business logic. So I want to, you know, I have a microchain, but the microchain is used to host my application. So I need to deploy microchain. So business logic. So it will be deployed in microchain and the business logic, app logic. If you want to have a token, that's fine. So as I said earlier, so all this from now on, we will deal with the top layer. We will no longer deal with the bottom layer. Bottom is the mother chain. Now we will deal with microchain. So we will fire up some direct call, and direct call will not be processed in the bottom layer. It will be processed in the top layer. So the major difference is we have a sharding flag is 1. If it's 1, every node will notice, oh, that's a up layer function call, and it will forward it to the up layer. If it's 0, it will process on the bottom. So now let's, I have a very simple application. So this is my business logic. So it's a contract, smart contract. What it does has a, you know, value. You can treat it as a token or whatever meaning you want to give it to. And in the constructor, it initialized value to be 100. It has 2 functions. One is increase, the other is decrease. Increase is at 1, decrease just -1. So, okay, I have this already being compiled, and the compile code is this. So remember this one, with the interface, we fire up all the transactions into the mother chain. We will make the microchain call also in this, but now today it's not available yet, unfortunately. So I will fire up this transaction from the console, from my local console. See, so this is one, the console connect to my local vnode. So let me see. I need what I needed to set up this transaction. So I need to send from anyone from my local account, and I need to send to the subchain, the microchain address. So I need to specify this. So because that's the new transaction I just created, so I need to copy. And I have a shorter way to do this. Have this. So basically, here I have the ABI. I just load it, and I can have this ready. So load script. So now subchain base dot address. That's the one. Is this one? Let's just confirm A520. Yes. So this is the A520. So this is one. I just make it instead of just hard code, and provide a gas and the gas price. Remember the sharding flag. We have to set it to 1 because it will be routed to the top layer. And there is another one. It's very interesting. We call it via, meaning we need to specify which function calls through which vnode, and that's important because we want to, for anyone provide a service for entry, they get paid. Okay, so let me load this script, and all I need to do is just deploy code. And remember, this is be executed in the top layer, so we do not have any feedback here. We don't have anything here. We will, however, there's one we can check. So from the monitor information, microchain information, see, this is all the 0 transactions. We can see if any transaction being executed by the top layer blocks, top layer miners. So, okay, oh, here it is. We have transaction executed here. Let's see. Okay, so remember we have a monitor being ready that can provide RPC service. So we have a way to interact with the RPC service. So basically, here's the monitor address, and that's the RPC service interface we can use. And what we can do is we provide this format, and it will give me the contract information. So we need to provide the subchain address in the RPC query, which is this one. This is the, okay, yeah, this one. So this is one that will query this microchain through the monitor, and it will send. Okay, let's do it again. Okay, we got some information back. So basically, we have balance and announce and code hash code. That's the code we recently deployed. This is code. Okay, so, and I have the storage, and we have the information we need. And let me do this again. Let's see, there are 2 transactions, which is a little bit abnormal, but I want to find out why. Okay, so, okay, so 109. So the next thing we can do is, remember in our in our app logic, we have a function called increase. So what we can do right now is we can call this, just execute this and see what's the value. So let me do this. Call. So already loaded. So it has a parameter, meaning the nonce. We need to specify the proper nonce. If the nonce is incorrect, it will be ignored. So remember, we already deployed once. So that's nonce 1. The second one will be 2. So file up the call on the upper layer again, and we check the monitor, see if the execution being executed. So last block is 110, 116, 116. It's still not there. Wait a while. Let's wait a while for it to update. Okay, so I think why? Because we deployed this and accidentally we called this already. So I need to call this with nonce of 3, see what happens. So my assumption is this time it will succeed. So let's see, 117 block. Okay, here we go. So in 120, block 120, this function get executed. So let's query this again. Remember the value was 65. Let's do it again. Okay, so being increased by 2, by 1. Okay, so we can do it again. Increase, remember, by 4. Let's check. This one last block is 120. Okay, 124. So 120, one transaction executed, and 124, another transaction executed. So we can sure that the state, this will increase by 1 as well. Yeah. Okay, so well, to summarize, so basically, we need to, the direct call will be file up from the bottom, but it will be actually executed on the top layer. And you can use the RPC service to query the state. This one is very obvious. We only have one data member in the system in this contract. So if I have a complicated one, you should be able to get a list of your variables, data members. And we will provide a better interface, similar to this, instead of launch from the terminal. Okay, let me see. So we covered this already. So this is the the query formats. I think that's pretty much it for today's demo. So to summarize, I deployed a Microchain. So vNode pool and SES pool are already publicly available. And I deployed a Microchain control logic first. And internally, the control logic will select 4 nodes from the pool. And those 4 nodes join my Microchain. And then I deploy a business logic, which is a simple smart contract, which only have 1 data member. And it's deployed on the top layer. And then I call on the business logic to increase the value. And it's also processed in the top layer. So, and everything can be viewed from the Explorer in this Microchain page. I think that's pretty much today's demo. Let me see if anyone has any questions. Anyone can anyone how can I get the presentation after the session? It will be posted online. Okay. Yeah, the same question. Okay, so I leave this to you know, to the audience. Who have any questions, you can ask me. Let me put this back, hopefully. Let's see. Okay, chat. Okay, so all right, so what's the limitation of drawback of Microchain, if any? So a lot of information. Okay, so one asks, what's the drawback of Microchain? So obviously, Microchain cannot solve everything. What it does is try to solve the existing bottleneck of Ethereum and provide a better architecture for DAPP. And hopefully we can create a DAPP friendly environment and make, you know, make DAPP so easy to deploy a microchain. So if you have a if you want to deploy a DAPP right now, so your first approach maybe just deploy a smart contract in Ethereum. I think that's probably 90% of the developer want to do. However, you suffered a couple of problems. One is, you know, it's expensive. So all your smart contract call need to pay gas. It's very expensive. And so normally you'll probably do some offline, you know, combination, try to consolidate multiple transactions into one, and try to maybe save some cost. So the other problem is, you know, it limits your user base. So basically, you pretty much require, you know, all your users will be from crypto community. If your user is from, you know, regular mobile network space, they don't have any user. They cannot execute any smart contract. They are being automatically being, you know, shut down from your application. I think that's not what application developer wants. So we create a microchain architecture, meaning every user can just use the application right away without paying any gas. So I think the drawback is, you know, we are still in our early stage. We have all the features ready, but we, you know, as a big platform like us, we provide a lot of things, and we try to solve a lot of problems. And we know we can solve a lot of them, but there are some, when we are also sure there's some problem we cannot solve. And also at the early stage, we probably still have a lots of bugs, problems. And, you know, that's, you know, how the community will try to help us. You know, you can try to use our system. If you see any problem, give us a feedback. We will try to solve as soon as possible. So, but with all the potential and the capability we provide, we hope MOAC and with its microchain platform will provide a much useful platform for the application developers. And let's see what's next question. In short, this is adding one more layer to increase scalability. That's right. So basically, we have the bottom layer provide the security and decentralization. We have the second layer on top to increase scalability. Okay, how to use Python to write up a smart contract? Well, currently we only support Solidity and EVM. Later we will make it more, flexible. As you see, we have a second layer. Let's go to this slide. So, well, you probably don't want to change this too often, the microchain control logic. But for the business logic, you are open to use any other virtual machine, like Java virtual machine or Python, or even just, C++ binary. So only what you do is you just create your own consensus protocol and your own, how you handle your smart contract. And currently we released a Plugwin and Firestorm, which is using EVM, but in the future we can provide a more support on the other languages like Python or C++ or Java. That's possible. Okay. SCS node and V node must be a full node. Well, so first, SCS node and V node are different. SCS node, let me go to the top layer. So SCS node is just a process smart contract. We will release two separate applications. One is for SCS node, one is for V node. They are totally different. So V node, it could be a full node or could be a light node. That's okay. The only thing is it does not do mining. And SCS node is a different node. It runs on a different binary. Well, you can call it a full node as long as it's in microchain concern. So for the microchain itself, the node inside microchain, you can call it a full node for that microchain. So this one's done. Any other questions? Okay. Can I get the lesson video or the PPT from somewhere? I believe this is the webinar is on Zoom, so it has a video feature. So you should be able to it should be recorded and published somewhere. I will check with ideas, and they should be able to publish. And also, we will provide the slides in this presentation and all the applications. They should be already running available in the GitHub in the release section. See, we have 1.01. And well, the SCS module is not released yet, but it will release pretty soon. So we have this one already running, and this one will be released maybe within a week. Okay. Any other questions? A lot of information. Yeah, it is a lot of information, basically, regarding the smart contract. It needs a lot of knowledge about how smart contract works and how internally those the blockchain works. Okay, so then you say the control logic is the controller to the microchain. The business logic is application layer contract that could be different for each microchain. It depends on the application microchain do. Is right? Yes. So, the control logic, we will release a standard template for control logic. All you want to do is you just need to specify some constructor parameters, like how many nodes you want, what the protocol you want to select, what vnode pool you want to select. So that's the well, no longer available anyway. And you can select how often you want to your microchain flush into the bottom layer. And yeah, that's pretty much. And for the business logic, it's up to you. So basically, this is my business logic. Obviously, it's very simple. You can create whatever you want. And the control logic, you will most likely you will use the template we provide. Okay, that's done. See any. Okay. Any other questions? If not, Randy, are you still there? Wait, maybe another question. And about synchronization between microchain and the mother chain, how it work? Okay, so in one shot, we do not need to synchronize between microchain and the mother chain. So they are each work independently. The only thing we need to do is we do flush. So like after 100 blocks, microchain want to flush its state, which you don't need to flush everything. You probably just flush a hash into the mother chain. So in that way, basically, your state had the state in the microchain has a finality, which is recorded in the mother chain. So in case anything happened, you want to, retrace back or whatever you want, you have a, checkpoint, which already written into the mother chain. And that's already done, you cannot change it. So you don't need to synchronize your state, your data storage into mother chain. Those data are only stored inside your inside the SES node. Obviously, they have all your blockchain data, and they also inside the monitor. So remember, monitor was synchronized with SES node. So all these nodes inside the microchain, they have all your data. Other than this node, no other node or anywhere will have your information of your microchain. Okay. Right. Okay, great. Thank you. Any questions? Done. Done. Okay. Anyone else have any questions? Okay. As a new learner, how to begin? Okay, that's a great question. So I think the first thing you probably want to need to try is, if you are not familiar with how smart contract works, you can, you probably do not want to dive into microchain too much. So later we will release a one-click deploy a microchain feature. So in that case, you probably don't need to understand the behind thing scenario, how microchain is created. So all you need to focus is on how smart contract works. Anyway, because for your application, if you want to deploy the APP, all you need to focus is on the APP business logic. Basically, most likely it's a smart contract, and you just need to focus on that. And we provide a whole set of architecture for you to deploy your smart contract into the microchain. So if you want to start, I think you can, you can try how to deploy how smart contract works, how to deploy a smart contract, how to execute a smart contract function, and how the data inside this smart contract being stored. And then you have a better idea how smart contract works, and then you can develop a smart contract specific for your application. I think that's the way. And we try to make it as simple as easier as deploy a smart contract in Ethereum. And then we want to get rid of all the tedious work to create a microchain. So that's our goal. Okay, hopefully this answers your question. What are different resources to learn Solidity? Well, I think with the way why we choose Solidity is because Ethereum has put a lot of efforts to improve the to lower down the learning curve how to use Solidity, and there are lots of tutorials online, and we want to make it, our platform to be utilize that already available resources. So you can get into the Ethereum develop network, and you can learn Solidity there, and there are lots of great tools like Truffle, and there are like a Remix website. You can step debugging your application. So there's a lot of tools available there. Yeah, okay. All right, any more questions? Can I use MetaMask to manage MOAC? That's one thing we want to work right now. So as I said earlier, so we as I said earlier, this is typically a MetaMask setup works. So you have application, you will install a MetaMask plugin in your browser. So whenever you want to access the Microchain blockchain smart contract, you will using MetaMask. So assume this is a MetaMask. You will go in through this way, and we provide a different way. But we want to this way still works. So we want to make MetaMask compatible with Microchain setup, but there was a little bit, updates need to be created to be done before we release the MetaMask. But yeah, we are working on this for MetaMask-like work. But we will make it more generalized in this way. So meaning you can have multiple, decentralized access into the microchain to access IPC service. Okay. All right, so if no more questions, I will give this back to the host. I will stop share my screen, and Randy is not here anymore, but I think it's okay. I appreciate everyone to join this webinar. So this is a you know, we released our mainnet like 3 months ago. We actually, yes, 3 more months ago. And we released our microchain features end of last month, a week ago, half a week ago. So want to make it, you know, easy for app developers to better to use blockchain easier. So that's our goal, and we will provide a similar seminar or webinar in the coming weeks. And thank you very much for attending, and I hope to see you guys in the future. All right, thank you.